picture this, You've just been hired to manage a small, independent bookstore.
Oh, that sounds nice. Kind of a dream job for a lot of people.
Right. Well, the owner originally thought she could handle all the customer requests by herself, maybe using just a few part-time college students as cashiers.
Yeah, that usually doesn't scale well.
Exactly. So you walk in on your first day, and the place is absolutely packed. I mean, there's a line out the door. The phone is just ringing off the hook.
It's stressful right out of the gate.
Oh, totally.
Mm.
And a customer walks up to the counter, visibly in a hurry, tapping their watch, and they ask for a very specific, somewhat obscure book.
Of course they do.
Right. And they want to know right now, like, do you have it in hardcover? Who's the publisher? What genre is it? And, most importantly, is it actually sitting on the shelf right this second?
Oh, man. It's the classic retail nightmare scenario. I mean, the pressure is really on.
It really is.
Because if you don't know the answer immediately, you lose the sale. But, well, worse than that, you look completely disorganized. The customer just loses faith in the business entirely.
Exactly. And the tension in that moment is real. But, you don't panic. You don't go running down the aisles frantically, scanning the shelves, hoping you stumble across the right spine.
That would take forever.
Right. And you don't have to somehow memorize the entire store's inventory of 10,000 books.
No, thankfully.
Instead, you turn to your computer screen, you type in a few keystrokes, and within, 2 seconds, you look back at the customer and tell them, yes, we have one hardcover copy left.
Boom. Just like that.
Yep, it's published by Penguin, it's historical fiction, and it arrived in our store exactly 2 weeks ago.
Which is amazing.
It is.
Yeah.
And you didn't use magic. You didn't even use some multi-million-dollar proprietary software suite. You used the absolute foundational tool of modern business.
Use a spreadsheet. And what's truly amazing about that is whether you're running a tiny corner bookstore or you're, managing a massive global supply chain moving freight across the Atlantic, that fundamental mechanism stays the same.
It really does.
Organizing, retrieving, and manipulating your daily data, I mean, it's exactly the same tool.
It is the great equalizer in business. But before we get into the nuts and bolts of how you actually built that bookstore inventory system, let's take a quick step back.
Yeah, good idea.
Let's do a brief recap of what we covered in Module 3, which was all about data analytics, because it perfectly sets the stage for what we're diving into today.
Right. So in that previous deep dive into the source material, we were looking at the massive, almost incomprehensible ocean of data that businesses deal with today.
Oh, yeah. Huge amounts of data.
We talked about data ecosystems, right? The massive architecture and infrastructure that companies build to handle all this information.
We talked about data-driven decision-making, or DDDM. The idea that in modern business, you aren't just guessing anymore.
No, gut feelings don't cut it anymore.
Exactly. You're using hard facts and metrics to guide your strategic goals. And we broke data analytics down into those 3 distinct phases.
Right. You had descriptive analytics, which tells you what happened in the past.
Right.
And then predictive analytics, where you use statistical modeling and AI to guess what might happen in the future.
Yeah, that's where it gets really cool. And then prescriptive analytics, right? The really advanced, almost sci-fi stuff, where the data actually tells you what course of action you should take next.
Exactly. And we also looked at the heavy hitters in that enterprise space. We talked about using SQL or structured query language to pull specific info out of massive relational databases.
Yeah, SQL's huge.
And we talked about using Python for data science. And we looked at incredibly powerful visual dashboard tools like, Tableau and Microsoft Power BI.
And all of those tools are incredible. I mean, they are legitimately changing the world. But here is the thematic bridge to today's topic.
Okay, lay it on me.
You cannot run predictive AI models. You can't build a beautiful Tableau dashboard. And you certainly can't make reliable data-driven decisions if your raw, everyday data is a complete mess.
Oh, 100%. It's impossible.
Right. While AI and SQL are doing the heavy lifting in the background for enterprise data, the foundational stepping stone, like the ultimate everyday tool for organizing and cleaning data on a daily basis, is the spreadsheet.
Yeah, it's basically the sandbox where all data analysis actually begins.
That's a perfect way to frame it. You have to walk before you can run.
Exactly. I mean, you can't feed garbage data into an AI and expect a brilliant business strategy.
Garbage in, garbage out.
Right. And in the business world, walking means mastering the spreadsheet.
So with that in mind, I want to officially welcome you to Managing the Future, the MIS podcast, produced specifically for the Dr. Sam Pack College of Business students at Tarleton State University, as well as any working professionals joining us today.
Glad to have you all here.
Today's deep dive into the source material is covering Module 4, Spreadsheets. And this is drawn directly from ConnectMaster, Management Information Systems, by Richard Tedmon and Casey Wilhelm, the 2026 release from McGraw-Hill.
It's going to be a highly practical session today, too. We're taking all those high-level theoretical concepts of data from the last module and applying them to the actual screen you probably stare at every single day at work or in class.
Yeah, it's very hands-on today. And really quickly, before we jump in, we want to invite you to like, subscribe, follow, share, and comment on this feed.
Yeah, definitely hit that subscribe button.
It's the absolute best way to stay updated with your coursework, and we really do want you to join the conversation. We'll have a specific real-world question for you to answer in the comments at the end of this deep dive.
All right, let's get into it.
Okay, let's unpack this. We need to start by defining our terms. What exactly are we looking at when we open one of these programs? How do we officially define what a spreadsheet is?
Well, at its most basic level, a spreadsheet is a computer program that allows users to easily arrange, calculate, and present numerical data.
Okay, pretty straightforward.
Yeah. It takes raw information, numbers, text, dates, and structures it into a highly organized grid of rows and columns.
Right, the classic grid.
But the real power, the reason it's not just a digital piece of graph paper, is that it provides built-in formulas to compute numerical equations automatically.
That's the key right there.
And it allows you to instantly convert those tables of raw, boring data into dynamic charts and graphs so you can actually recognize trends visually.
It's just ubiquitous. I mean, it would be hard to imagine running any business anywhere in the world without making use of a spreadsheet in one way or another.
Oh, absolutely impossible.
The text points out a few specific, incredibly common business uses, like budgeting and accounting is a massive one.
Oh, definitely. Keeping track of budgets is the absolute bread and butter of spreadsheets.
Right.
In fact, if you look at dedicated, expensive accounting software, programs like QuickBooks, they are fundamentally just relying on underlying spreadsheet logic and functions.
Wait, really? Just a spreadsheet underneath?
Yeah, exactly. They've just built a very specific, user-friendly, prettier interface on top of the raw spreadsheet engine.
That makes so much sense.
Yeah.
Finance is another huge area, tracking financial trends over time, and then, crucially, converting that historical data into charts to show investors or the board of directors.
Right, because nobody wants to look at a wall of numbers.
Exactly. But it's not just corporate finance. Teachers and professors use them constantly for grading, which we'll actually walk through a specific example of later.
Yeah, that's a really good example.
But even sports. Almost every single statistic, every lap time, every baseball box score you see in a sporting event is being tracked, sorted, and analyzed in a spreadsheet behind the scenes.
Now, when we talk about spreadsheet software, there isn't just one program. The market it's evolved.
Right, there are options now.
There are really four main players that the text highlights, the big four, if you will, that you're likely to encounter in your professional career.
Let's compare and contrast them because they are definitely not all created equal. First up, the undisputed industry heavyweight, Microsoft Excel.
Excel is the gold standard. I mean, it's what people generally mean when they just say, hey, can you send me a spreadsheet?
Yes, the clean access spreadsheet.
Exactly. It's a desktop and cloud-based application that's part of the broader Microsoft Office suite.
Right.
Visually, like all Microsoft Office products, it uses that highly distinctive ribbon across the top of the screen to display all of your formatting, data, and formula options.
Oh yeah, the ribbon. Very iconic.
To open it, you're typically clicking your Start menu on a PC, finding the Excel icon, and selecting Blank Workbook. Its reputation really comes from being incredibly powerful.
Yeah, it can handle a lot.
It handles massive data sets smoothly and allows for incredibly complex financial modeling and macro programming that, frankly, other software struggles with.
Then you have the great disruptor, Google Sheets. This one has just exploded in popularity over the last decade, especially in education, startups, and highly collaborative work environments.
What's fascinating here is the core philosophy behind its design. Google Sheets was built from the ground up to be cloud-based.
So no downloading heavy software.
Right. You don't install a heavy program on your hard drive. You access it entirely through your web browser by logging into your Google account.
Just going to the apps launcher, clicking Google Drive, and selecting a new Google Sheet.
Exactly. And visually, it's a bit cleaner and more stripped down than Excel. Instead of a massive, dense ribbon, it uses traditional drop-down text menus, File, Edit, View, Format.
And a much smaller row of shortcut buttons.
Yeah.
But the real reason businesses use it isn't just because it's clean. It solves a massive pain point.
Oh, a huge one. Its main selling point is asynchronous and real-time collaboration.
Right.
Multiple people can be working in the exact same spreadsheet at the exact same time from different countries without locking each other out.
Which used to be such a nightmare. Before this, you had the version control chaos.
Oh, the worst.
You'd have a file called budgetfinal.xlsx. You email it to a colleague, they make changes, and save it as budgetfinal v2.
And then send it back.
Yeah, and then send it to the boss, who saves it as budgetfinal free actual final. It was just chaos.
Google Sheets eliminated that by having one single source of truth in the cloud.
The third one mentioned in the text is OpenOffice Calc.
Right. OpenOffice Calc is part of the Apache OpenOffice suite. The defining characteristic here is that it's open source software.
Meaning it's entirely free to download, use, and modify.
Exactly. It looks a bit more traditional, kind of like early 2000s software, using a combination of top text menus and a double row of standard buttons, rather than a thick, modern ribbon.
Okay, so you'd open it from your start menu just like Excel, selecting Spreadsheet from the OpenOffice folder.
Yep, that's it.
But why would a business choose OpenOffice over Excel or Google?
Cost. Plain and simple. If you're a small business or a startup trying to keep overhead low, outfitting 50 computers with Microsoft Office licenses is incredibly expensive.
Oh yeah, that adds up fast.
OpenOffice gives you 90% of the functionality of Excel for $0.
And finally, for the Mac users out there, Apple Numbers.
Right. Numbers is part of Apple's iWork suite. It has a very distinctly Apple design aesthetic. It's very clean, very beautiful.
It uses large, intuitive buttons across the top rather than a dense, intimidating ribbon.
Yeah, exactly. You open it via your Launchpad or Finder on a Mac. It's fantastic for making visually appealing reports and gorgeous presentations.
But what about the heavy lifting?
Well, power users doing complex million-row financial modeling still tend to gravitate back toward the raw processing power of Excel.
Makes sense. So those are the four main programs. But regardless of which one your company uses, when you open a blank document, you are staring at the exact same thing, a massive grid.
Yes, the grid.
Let's break down the actual anatomy of that workspace.
The grid is the foundation. It's made up of rows and columns. A row is a horizontal line of cells going from left to right.
Okay, got it.
And rows are always universally identified by numbers going down the left side of the screen. So 1, 2, 3, 4, and so on, all the way down into the millions.
So if you physically click on the number 5 on the left margin, it highlights that entire horizontal row all the way across the infinite spreadsheet.
Yep, exactly.
And columns are the vertical lines going up and down.
Correct. Columns are vertical and are identified by letters across the very top, A, B, C, D. And when it runs out of the alphabet at Z, it just starts over with A, B, A, C.
Just like rows, if you click the letter B at the very top, it selects that entire vertical column all the way down to the bottom of the document.
You got it. And where a row and a column intersect, well, that creates the actual box you type in, a cell.
The cell.
Yeah, the cell is the basic unit, like the fundamental building block of any spreadsheet. It's the individual little box where you actually input your raw data.
And every single cell in that massive grid has a unique name, right?
Yeah.
Which we call a cell address or a cell reference.
Yes. It's like a coordinate on a map. It's always the column letter followed immediately by the row number. So the very first box in the extreme top left corner is A1.
Okay.
If you go to the third column over, which is C, and the fixed row down, which is 5, that specific cell is C5.
So when you click on a specific cell, let's say A3, it becomes what the text calls the active cell.
Yes, the active cell is simply the one you have currently selected and are about to work in.
Makes sense.
Because the grid is so massive, the program has to visually let you know which cell is active. It does this by putting a heavy, bold border around that specific box.
Oh, right. So it stands out.
Yeah. Additionally, to help you keep your bearings, the row number 3 and the column letter A will usually light up, turn bold, or become shaded on the outer margins.
That's super helpful if you're scrolled way down.
Totally. Furthermore, programs like Excel and OpenOffice Calc feature a dedicated name box.
Oh, I've seen that.
Yeah, it's a little window located in the top left corner just above column A, which will explicitly display the text A3 so you always know exactly where you are, even if you've scrolled far away from the margins.
Now, I want to stop here for a second because this raises a really important structural question.
Okay, what is it?
In Module 3, we spent all this time talking about these incredibly robust relational databases. We talked about SQL. We talked about systems that can perfectly handle millions upon millions of rows of data without breaking a sweat.
Right, yeah.
If I'm running a modern business and I have access to massive, powerful, secure databases, why am I still relying so heavily on this basic grid-like spreadsheet? I mean, why not just put absolutely everything in a database and be done with it?
That is a crucial distinction, and the text draws a very clear line between the two based entirely on their structural constraints.
Okay, break that down for me.
Think about a database. A database is structured using strict, unforgiving rules and relationships defined by a database management system, or DBMS.
It's very rigid.
Very. Data entry in a database is highly constrained by defined parameters. If a database field is set up by an engineer to only accept a date format, and you try to type the word Tuesday into it, the database will aggressively reject it.
It just throws an error.
Yep. It throws an error. It forces data integrity. It's essentially a vault.
So it's designed to protect the data from human error. You can't just, mess around in a database.
Exactly. A spreadsheet, on the other hand, is entirely flexible. It's a blank canvas.
Which is great for everyday use.
Yeah, the text notes that spreadsheets often require manual data entry that is not constrained. You can type a date in one cell, a long paragraph of text explaining your feelings in the cell right next to it, and a complex math formula right below that.
And the spreadsheet doesn't care at all.
Not even a little bit. It gives the everyday user absolute freedom to manipulate, organize, and visually analyze the information on the fly without having to write complex SQL code, without asking the IT department for permission, and without building new database tables. Databases are for the secure, structured, long-term storage of massive enterprise data. Spreadsheets are your personal, flexible workbench for pulling out a chunk of that data and actually analyzing it to make a decision today.
I really love that analogy. The database is the vault and the spreadsheet is the workbench.
Exactly.
So let's talk about putting raw materials on that workbench. We're moving into data entry. According to the text, we have two main types of data that we enter into these cells: labels and values.
This is a fundamental concept that dictates how the software engine treats your typing. A label is essentially text.
Just words.
Right. It's information that helps the human user identify what the data actually is. It provides context. So typing first name at the top of a column or typing apples in a grocery inventory list.
Okay.
A label does not interact with other cells mathematically. The software knows you can't multiply the word apples by 5.
That would be a neat trick, though.
It would. And you can always tell when the program recognizes your entry as a text label because, by default, it will automatically align the text to the left side of the cell.
And the other type is a value.
Right. A value is an entry that the spreadsheet engine recognizes as numerical data that can interact mathematically with other cells.
So numbers.
Values are your numbers, your dates, your financial figures, your percentages. When you type the number 50 into a cell and hit enter on your keyboard, you'll notice it immediately jumps to the right side of the cell.
Oh, I've noticed that.
Yeah, that visual shift, labels hugging the left wall, values jumping to the right wall, is the program's silent way of communicating with you. It's saying, I know what this is, it's a number, and I am ready to calculate it if you ask me to.
But wait, here's where we hit some logical friction. The text highlights a very specific formatting trick, and it's something that trips up new professionals all the time.
I know exactly what you're going to say.
What if I have a number, but I absolutely need the spreadsheet to treat it as a label?
Yeah, this happens a lot.
Like, think about an employee ID number, like 12345, or a product CQ, or a zip code. I am never, ever going to mathematically add two zip codes together.
That would be completely pointless.
I just want the number to sit there as text. But if I just type 12345, the program is going to stubbornly treat it as a value and push it to the right.
And that can cause massive headaches, especially with things like zip codes on the East Coast of the United States that start with a 0.
Oh no, the leading 0 problem.
It's the worst. If you type the Boston zip code 02134, the spreadsheet thinks it's a math value, decides the leading 0 is mathematically useless, deletes it, and just displays 2134.
And it ruins your entire mailing list.
Completely ruins it.
So how do I stop it from doing that? If I have 10,000 employee IDs, what do I do?
Well, the text highlights a specific character-level override trick for this, the single apostrophe.
The apostrophe.
Yeah. If you type a single apostrophe before the number, so you literally type apostrophe 12345, the spreadsheet program will instantly recognize that you want this number treated as a text label.
It's like a secret code.
It acts exactly like a secret signal. When you hit enter, the software will hide the apostrophe visibly so your report still looks clean, but it will keep the number aligned to the left side of the cell, it will keep any leading zeros intact, and it will absolutely refuse to include it in any accidental math calculations.
That is so good to know.
Now, to address your point about 10,000 IDs, yes, you can highlight a whole column and change the format to plain text in the menu, but understanding the apostrophe trick is crucial because it's the fundamental cell-by-cell way the engine distinguishes text from math.
That makes a ton of sense. It's a manual override.
Ah.
Now, speaking of talking to the engine, let's talk about the single most important symbol in the entire spreadsheet program, the equals sign.
Oh, yes. The equals sign is the trigger. It is the most powerful key on your keyboard when you have a spreadsheet open.
The analogy I always come back to here is that the equals sign is exactly like turning the ignition key in a car.
I like that.
If you just sit in the driver's seat and press the gas pedal with your foot, absolutely nothing happens. The car is just sitting in park.
Mm-hmm.
In a spreadsheet, if you select a cell and just type 2 plus 3 and hit enter, the software just looks at it as a text string.
Yeah, it literally just displays 2 plus 3 on the screen.
Right. It thinks you're just writing a label, maybe writing out a math problem for a student to look at.
But the moment you type that equals sign first, so you type equals 2 plus 3, you have just turned the ignition. You've sent a command to the software engine to stop recording plain text and wake up the internal calculator.
And then boom.
You hit enter, and the cell doesn't show your formula anymore. It shows the calculated result, 5. The formula is still there, hiding in the background, which you can see if you look up at the formula bar at the top of the screen, but the cell displays the output.
So every single formula and built-in function we discussed today must, without exception, begin with that equal sign.
Absolutely, no exceptions.
Before we start revving that engine and doing complex math, we should briefly cover how you physically navigate the workbench. Depending on what you're hovering over or trying to do, your mouse pointer actually changes shape in a spreadsheet to tell you what tool you're holding.
Yes, the cursor is highly dynamic. It constantly communicates what action you are about to take.
Okay, what's the most common one?
The most common is the standard selection cursor. In Google Sheets, Apple Numbers, and OpenOffice Calc, this is just your normal arrow pointer.
In an Excel?
In Excel, it takes the shape of a thick, hollow, white cross. You use this simply to click and select a single cell, or you click and drag to highlight a large group of cells.
Got it. Then you have the insertion tool.
Right. The insertion tool looks like a capital I or a thin vertical cursor line. You see this when you double-click directly inside a cell or click up into the formula bar.
So it means you're typing.
Exactly.
Okay.
It means you're now in text editing mode, inserting data character by character directly into the text string of that specific cell.
But what about when I'm typing a long label, maybe a whole sentence, and my text is too long and spills out over the edge of the cell, bleeding into the next column? We've all seen that mess.
Oh, sure. That's where you use the column or row expansion tool.
How does that work?
If you move your cursor up to the very top row, the header row where the column letters are, and hover exactly on the borderline between, say, column A and column B, your cursor will magically change into a cross with little arrows pointing left and right.
Okay, I can picture that.
That visual cue means you can now click and drag that borderline to physically make the column wider.
Oh, nice.
Or even better, if you just double-click that borderline, the software will automatically auto-fit the column perfectly to whatever your longest line of text is. The exact same concept works vertically on the numbered rows to adjust row height.
That double-click trick saves so much time. And finally, we have what is arguably the most powerful pointer in the entire program, the fill handle.
Oh, the fill handle is an absolute game changer for workplace efficiency.
Tell me about it.
If you select an active cell, you'll notice a tiny, slightly darker square located in the very bottom right corner of that heavy active border. If you take your mouse and hover precisely over that tiny square, your cursor turns into a very thin, solid black cross.
That's the fill handle.
That is the fill handle. If you click and drag that cross down a column or across a row, it autofills the adjacent cells. It can copy the data exactly, or, amazingly, it can recognize logical patterns.
Like days of the week.
Yes.
Yeah.
If you type January and drag the fill handle down, it automatically types February, March, April. If you write a complex mathematical formula in row 1, you can grab the fill handle, drag it down an entire column of 10,000 rows, and it will calculate the math for every single row in less than a second.
Which perfectly transitions us into the math itself. We've got our data entered. We know how to turn the ignition with the equal sign. Let's talk about how the engine actually processes the numbers. Spreadsheets don't just calculate blindly left to right like we read a book. They strictly follow the order of operations.
They absolutely do. Spreadsheets are rigidly programmed to follow the mathematical protocol you probably learned in middle school algebra.
Good old PEMDAS.
Exactly, often remembered by the acronym PEMDAS. That stands for parentheses, exponents, multiplication, and division, which are handled together as a pair, reading left to right, and finally, addition and subtraction, also handled together left to right.
So it's not a suggestion.
The order of operations is vital. It is a law. Because placing parentheses in a slightly different spot changes the entire result of the calculation.
And if you're building a financial model, that can mean the difference between showing a profit and showing bankruptcy.
Truly.
The source text gives us a great concrete example to work through to prove exactly why this matters. We have a mathematical expression, 6 plus 8 divided by 2 times 2 squared.
Okay, let's write that out as a spreadsheet formula and actually walk through how the software engine solves it internally.
Okay, the formula typed into the cell is equals 6 plus 8 divided by 2 times 2 raised to the power of 2. The little caret symbol, which is Shift 6 on your keyboard, is how we tell the spreadsheet to calculate an exponent.
Okay, let's run that exact string through the engine using the PEMDAS protocol. Are there any parentheses in that equation? No. So we move to the next letter, exponents.
Okay, we have a 2 squared at the very end.
Right. The spreadsheet calculates that first before it even looks at anything else. 2 squared is 4. So now our internal equation held in the computer's memory is updated to 6 plus 8 divided by 2 times 4.
Next up in PEMDAS is multiplication and division, moving left to right across the equation.
Right. Reading left to right, the first division or multiplication symbol it hits is the division sign between 8 and 2.
8 divided by 2 is 4.
Exactly. So now the equation drops down and simplifies further to 6 plus 4 times 4.
We're still on the multiplication and division step, so we keep moving left to right, and it hits the 4 times 4.
4 times 4 is 16. The equation is now simplified down to just 6 plus 16.
And finally, we arrive at the ANS, addition and subtraction. 6 plus 16 equals 22. So if you type that original formula into a cell and hit enter, the cell cleanly displays the number 22.
But watch what happens when we use the exact same numbers and the exact same math operators, but we add 2 sets of parentheses to force the spreadsheet to prioritize differently.
Okay, what's the alternative formula?
The text gives the alternative formula. Equals, open parentheses, 6 plus 8, close parentheses, divided by open parentheses, 2 times 2 squared, close parentheses.
Okay, the engine sees the equal sign, turns on, and runs PEMDAS again. Parentheses are first. We have 2 sets this time. Let's see the first one on the left, 6 plus 8. That easily equals 14.
Now it looks inside the second set of parentheses on the right, which is 2 times 2 squared. But wait, inside those parentheses, we have a complex equation.
Oh, so it has to run PEMDAS again inside the parentheses.
Exactly. The software has to follow PEMDAS again inside. Exponents come before multiplication. So it looks at the 2 squared first, which is 4. Then it takes that 4 and multiplies it by the 2. 2 times 4 is 8.
So that entire second set of parentheses resolves mathematically to 8.
Right. So our main overarching equation has now been simplified by the engine down to just 14 divided by 8.
And it does that final division.
Yeah.
14 divided by 8 equals 1.75.
Look at that difference.
The exact same numbers, the exact same symbols. But 22 versus 1.75 is a massive fundamental difference.
It's huge.
If you're a business manager calculating millions of dollars in a financial model, a misplaced parenthesis doesn't just give you a slightly wrong answer, it gives you a catastrophically wrong answer. You absolutely have to understand how the spreadsheet is reading your math.
And the scary part is, if you do the math wrong but the syntax is valid, the spreadsheet will happily display 1.75 and let you make a terrible business decision.
Yeah, it won't warn you.
But if you type something structurally wrong, the spreadsheet engine is going to throw an error code. It's going to yell at you.
Yes. Let's talk about the yelling, the dreaded error codes. Let's translate the common error codes that students and working professionals see pop up in their cells and explain what the machine is actually complaining about.
That idea?
The first one from the text is value E with a hashtag and an exclamation point.
The value error is the spreadsheet's way of telling you that the operation or function you entered is simply not possible because the data types you referenced are completely incompatible.
What does that look like in practice?
The classic example. You type the number 20 into cell A1. Then you type the word panda into cell A2. Then in cell A3, you write the formula equals A1 plus A2.
Oh, I see.
You are explicitly asking the spreadsheet engine to mathematically add the number 20 to a bamboo-eating bear. It can't do it. It throws the value error in cell A3 to tell you, I cannot mathematically calculate this request. Fix your data.
The next error we see a lot is div0.
This one is a straightforward mathematical impossibility. You are attempting to divide a value by 0.
Which you can't do.
Right. In mathematics, division by 0 is undefined. The spreadsheet engine is programmed to know this, and it throws div0 to let you know your denominator is either an explicit 0 or, more commonly, it's pointing to a completely empty cell.
I've done that.
Yeah, this happens a lot if you're building a template and referencing a blank cell that you meant to type a sales figure into later. The moment you put a number in that blank cell, the error vanishes and the math works.
Then we have ref. No, this is the dangerous one.
Very dangerous. REF stands for reference. This indicates an invalid cell reference.
How does it usually happen?
This almost always happens when you build a formula pointing to a specific cell. Say you have an entire column of gross sales, and your formula multiplies those sales by a local tax rate that you type specifically into cell C5.
Okay, so normal.
But a week later, someone else opens the spreadsheet, thinks column C is just taking up space, and accidentally deletes the entire column C entirely. The formula in your sales column turns on, goes looking for that specific tax cell, realizes the physical target has vanished from the grid entirely, and throws REF to tell you the destination no longer exists.
And if you don't catch that, your entire sheet's calculations cascade into failure. Okay, and finally we have a string of hashtags straight across the cell, just hashtag, 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 hashtag.
What's absolutely fascinating here is how much time, energy, and stress business professionals waste panicking over the hashtag symbol. I see it constantly in offices.
I mean, it looks bad, like the files is corrupted.
People think they've accidentally deleted their data or corrupted a vital company file or broken a complex macro, but the text explicitly clarifies that this is not an error value at all.
Wait, it's not an error. The software isn't complaining.
No, it's not complaining about the math. It simply indicates that the numerical value successfully calculated inside the cell is physically too wide to be displayed within the current column width.
So it just doesn't fit.
Imagine trying to fit a 10-digit phone number into a box only big enough for 3 digits. It's the spreadsheet's way of saying, I have done the math, the data is perfectly safe, but I don't have the physical screen real estate to show it to you without cutting off important digits and misleading you.
So wait, seriously, you just drag the column wider?
Yep. That's literally it. All you have to do is take that column expansion tool we talked about earlier, hover between the letters, drag the column to make it a little wider, and the hashtags magically disappear, revealing your perfectly intact data.
It's purely a visual formatting issue, not a data corruption issue. Okay, deep breath. We've got our data in, we know how to do complex math, we know how to fix the errors when the software yells at us. Let's move to section 4, cell referencing and basic built-in functions.
This is where things get really efficient.
We touched on this briefly when we talked about the magic of the fill handle, but we need to formally define a critical concept, relative versus absolute cell referencing.
This is undoubtedly one of the most powerful concepts in spreadsheet architecture, and it's also the one that causes the most frustration for beginners.
I can attest to that.
By default, spreadsheets use relative referencing. This means that when you write a formula referencing a cell and then you copy or drag that formula to a new location, the cell references inside the formula automatically change relative to where you moved it.
I'm going to need a concrete example for this. Why would I want my formula to change on its own?
Let's say you're calculating payroll. In cell C1, you write a formula to add the regular pay in A1 and the overtime pay in B1. So you type equals A1 plus B1.
Simple enough.
Now you have 100 employees below that. You take your fill handle and drag that formula down one row into cell C2. The spreadsheet doesn't just dumbly copy the exact text equals A1 plus B1.
What does it do?
The engine thinks, the human wants to add the two cells directly to the left. So in cell C2, it automatically updates the formula to equals A2 plus B2. It shifts the row numbers relatively based on its new location.
Oh, I see.
This is incredibly useful because it allows you to calculate a whole column of hundreds of individual inventory totals in one simple drag.
I get that. That is efficient. But here's my pushback, and this is where I see people want to throw their laptops out the window. What if I don't want the software to be smart? What if I don't want it to change my reference? Let's say I have a list of 100 different employee salaries in column A, and I want to multiply every single one of those salaries by a standard 5% annual bonus.
Okay, typical scenario.
I don't want to type 5% 100 times, so I type 5% into one specific master cell at the top of my sheet, let's say G1.
Right.
If I go to my first employee and write equals A1 times G1 and drag it down, well, the A1 becomes A2, which is great. But the G1 becomes G2, then G3, then G4.
Yeah, it shifts relatively.
But my 5% bonus isn't in G2 or G3. Those cells are completely empty. The formula multiplies the salary by 0, and the whole system breaks. Why doesn't the software know I only want G1?
Because the software's default setting is pattern replication, not mind reading. To stop the reference from moving, to tell the software, do not touch this specific coordinate, you have to manually lock it down using what we call absolute referencing.
Absolute referencing. How do we do that?
To create an absolute reference, you identify the target cell, but you place a $ symbol in front of the column letter and another $ in front of the row number.
Okay, if you're a listener stepping into a financial analyst role, or managing a small business budget, or just taking the quiz for this module, pay close attention to this. Missing that $ will literally ruin your financial models.
It really will. So, to fix your bonus problem, instead of typing equals A1 times G1, you would type equals A1 times $G $1.
Oh, that's brilliant.
The A1 is left alone. It remains relative, so it will correctly change to A2, A3, A4 as you drag down the employee list. But the $G $1 is absolute. It is bolted to the floor.
So it never moves.
Exactly. Every single row will now successfully multiply by the exact 5% value sitting safely in G1.
The $ locks it down. Okay, so that is how we reference cells properly. Now let's look at what we can actually do with those references without having to manually write out huge, complex math equations.
Right, because we want the software to do the work.
Spreadsheets have prepackaged, built-in formulas ready to go called functions, and the absolute most common one is AutoSum.
AutoSum is so universally used in business that it usually gets its own massive dedicated button on the main ribbon shaped like the Greek letter sigma.
Yeah, that big E-looking thing.
Exactly. If you have a column of 50 monthly expenses, you don't sit there and type equals A1 plus A2 plus A3 plus A4 all the way to 50. That defeats the purpose of a computer.
It would take forever.
You just click the empty cell at the very bottom of the expense list, click that sigma button, and the spreadsheet engine automatically looks up, grabs the contiguous block of numbers, and writes the formal function equals sum open parentheses A1 colon A50 close parentheses for you. You just hit enter and you have your total.
And it also works horizontally across rows if you're tracking daily sales across a week. And usually right next to that AutoSum button, there is a little drop-down arrow that gives you instant access to other fundamental functions.
Right. You have the average function, which automatically adds up the selected range of cells and divides by the total number of entries to give you the mean.
Super useful.
You have the count function, which simply scans a range and tells you exactly how many cells actually contain numerical data, ignoring blank cells or text labels.
And then there are the min and max functions. The textbook uses a highly relatable example of a teacher using these to save hours of manual labor.
Let's walk through it. Imagine a teacher has a spreadsheet with 200 student exam grades listed in a single column. The teacher needs to quickly know the absolute highest score and the absolute lowest score to determine if they need to establish a grading curve.
And they certainly don't want to scroll through 200 rows, scanning manually with their eyes, trying to remember the lowest number they saw.
Right. They simply click an empty summary cell at the top, select the max function, and highlight the entire column of grades. The spreadsheet instantly scans all 200 rows and returns the absolute highest numerical value in that range.
That's amazing.
They do the same thing in the next cell with the min function to instantly find the lowest score. 2 clicks, and you have your data bookends perfectly established.
It is efficiency at its absolute finest. Okay, moving on. We've built the foundation. We know how to enter data and do math. Let's talk about Section 5, File Management, and the universal language of CSV.
Ah, CSVs.
We all generally know how to save a file in Excel or OpenOffice, right? You go to File, Save As, you name the file, you pick a folder on your hard drive.
Yep, standard stuff.
If you're using Google Sheets, it saves automatically to your Google Drive in the cloud every few seconds, as long as you've given the document a name at the top. But the text heavily emphasizes one specific, highly important file format, the CSV. What exactly is a CSV?
CSV stands for comma-separated values. It might not look fancy, but it is undoubtedly one of the most vital file formats in all of modern business data management.
Why is it so vital? What makes it functionally different from just saving a standard Excel file?
Well, It comes down to file bloat and proprietary formatting. When you save a complex spreadsheet as an Excel file, the software saves absolutely everything. It saves your raw data, yes, but it also saves all your complex formulas, your absolute references, your bold fonts, your yellow highlighted cells, the specific column widths you dragged out, the charts you built.
So it's a very heavy, dense file.
Very. And crucially, it's strictly formatted so that only Microsoft's proprietary engine can perfectly read all those bells and whistles.
But in the real business world, systems have to talk to each other. What if I manage warehouse inventory and I need to send my daily stock levels to an external supplier and I have absolutely no idea what software they use?
That's a great point.
What if they use a custom-built legacy database from 2005 or an old version of OpenOffice, and they literally cannot open my fancy Excel file without the formatting breaking or throwing massive errors?
That scenario is exactly why you use CSV. When you go to Save As and choose the CSV format, the spreadsheet program aggressively strips away everything except the raw data values.
Wait, really? Everything else is gone.
No underlying formulas are saved, no bold fonts, no background colors, no column widths. It just takes the final calculated text or number of every single cell and separates them with commas in a brutally simple, plain text file.
So if I had a cell with the formula equals 2 plus 2 that was highlighted bright yellow, the CSV file just saves the plain text number 4.
Exactly. The yellow is gone, the formula is gone. And because it's just plain, unformatted text separated by commas, virtually every single spreadsheet, database, and analytics software in the entire world can open it and read it perfectly.
Yeah.
The textbook gives the prime example of a business needing to regularly send order, customer, or product data between different retail stores or corporate offices.
Right.
If the sender is working on a Mac using Apple numbers and the receiving office is using a MySQL database on a Linux server, sending a CSV ensures the raw data transfers flawlessly without any software compatibility conflicts.
You can think of CSV as the universal translator of the data world. It strips away the specific dialects and formatting of the software and just delivers the pure, unadulterated data meaning.
It is the raw, unrefined material that actually fuels those massive data ecosystems we talked about in Module 3.
Okay, we have covered the basics. We've built the workbench. Now we are diving into Section 6, Advanced Business Tools. These are the heavy hitters.
Oh, this is the good stuff.
Here's where it gets really interesting, because mastering these specific advanced tools is what separates the amateur, everyday spreadsheet users from true, highly valuable data analysts.
We are moving past just basic math and addition and moving into programming logic and automated data retrieval.
Let's start with logic. The IF function.
The IF function is incredibly powerful. It allows you to perform a logical test on a specific cell and then instruct the spreadsheet to return one specific value if the test proves true and a completely different value if the test proves false.
So you're essentially programming a basic decision-making tree directly into the spreadsheet.
Exactly.
The textbook uses a grading example again to illustrate this clearly. Let's walk through it. A teacher has a column of numerical grades. They want the next column over to explicitly state in plain English whether a student passed or failed the exam based on their numerical score. They don't want to type pass or fail 200 times.
Right. So let's say the first student's numerical score, an 85, is sitting in cell B2. In the next cell over, C2, you insert the IF function. The function is going to prompt you for 3 very specific arguments.
Okay, what's the first one?
First, it asks for the logical test. You type B2 is greater than 64. You are literally asking the program a question. Is the numerical value currently in cell B2 strictly greater than 64?
That's the test. A simple true or false question.
Second, the function asks value if true. You are telling it what to display if the answer to the test is yes. Because we want text, we put it in quotation marks and type pass.
And the third argument.
Third, it asks value if false. In quotation marks, you type fail.
You hit enter, and because the engine looks at 85, sees it is indeed greater than 64, the logical test is true, and the cell instantly displays the text pass.
And then the real magic happens. You grab that little black fill handle in the corner, drag it down the 200 rows of students, and in less than 2 seconds, you have a complete, perfectly accurate pass-fail roster calculated automatically without you having to evaluate a single score manually.
It's brilliant. Now, before we get to the next major function, the text mentions a structural tool called named ranges. What is that, And why do we bother using it?
We talked earlier about cell references like A1 or a range of cells like A1 colon A50.
Hmm.
But if you're building massive complex formulas that span multiple sheets, looking at a giant string of grid coordinates like absolute B, absolute 2 colon absolute B, absolute 200 can get incredibly confusing.
Yeah, it's just word soup.
It's hard for the human brain to read. A named range allows you to highlight a specific block of cells, right-click, and literally assign it a plain English name.
So instead of constantly typing and referencing that huge block of B2 to B200, I can just highlight that whole column of 200 grades once, right-click, and name the entire block final grades.
Exactly. Now, when you write formulas anywhere else in that entire workbook, you can just type equals SUM, open parentheses, final grades, close parentheses, instead of trying to remember the exact grid coordinate.
Oh, that makes it so much easier.
It makes your formulas highly readable for humans, which is crucial if you ever have to hand your spreadsheet off to a coworker.
Let's look at another highly practical real-world function, the payment or PMT function. This is something every single business student, and really absolutely everyone alive who deals with money, will use at some point when looking at a car loan or a home mortgage.
The PMT function calculates exactly what your fixed monthly payment will be for a standard loan. To use it, the software requires you to input 3 specific variables: the interest rate, the total number of payments, and the total initial loan amount.
But there is a massive, incredibly common trap here that people fall into, which the text points out.
Oh yeah, a huge trap.
Yes, the text is very clear about the math requirements here. Let's make this real. You are at the dealership buying a car. The bank offers you a 6% annual interest rate on a 5-year loan for a $20,000 car. If you open a spreadsheet and just plug the numbers 6, 5, and 20,000 into the PMT function, it's going to spit out a wildly, impossibly incorrect number. Why?
Because you are trying to calculate a monthly payment, but the bank gave you an annual interest rate and a time frame expressed in years.
The spreadsheet engine doesn't know that.
No, it just crunches the raw numbers you feed it. You have to manually match the units of your data to the frequency of your payment.
So inside the formula, you have to do some quick math first. You have to divide the annual interest rate by 12. You take that 6%, which is 0.06, and divide it by 12 to get your true monthly interest rate.
Correct. And then for the total number of payments, you have to multiply the years by 12. So 5 years times 12 months means you are making 60 total monthly payments. Your core loan amount, the $20,000, stays the same.
You plug those newly adjusted numbers in, rate divided by 12, years times 12, and the loan amount. You hit enter, and the spreadsheet instantly spits out your exact to-the-penny monthly car payment.
Which is incredibly helpful.
And because it's a flexible spreadsheet and not a static piece of paper, you can use it as a financial dashboard. You can sit there and change the loan amount to $18,000 to see what putting down a larger cash down payment does to your monthly bill. You can change the interest rate to 5% to see if refinancing is worth it.
The monthly payment updates in real time. It's an incredibly powerful tool for personal and corporate financial planning.
Now let's move into true data retrieval. This is where spreadsheets heavily bridge the gap toward database functionality. We're talking about VLOOKUP and HLOOKUP.
Mastering VLOOKUP is a true rite of passage in the corporate world.
VLOOKUP stands for vertical lookup. The text uses an example of a local group raising money by selling prepaid boxes of cookies. They have a massive long spreadsheet list of people who have prepaid for boxes.
Okay, good scenario.
You're volunteering, working the pickup table on a Saturday. A customer walks up and says, "Hi, I'm John Smith. I'm here to pick up my cookies." You absolutely do not want to scroll manually through 500 rows of names looking for John Smith while a line forms behind him.
No, you want to retrieve the data instantly based on a unique identifier. In this specific case, the customer's name is the identifier. So you build a VLOOKUP formula in a clean, dedicated search box at the very top of your sheet.
But wait, I look at the VLOOKUP syntax and it asks for 4 distinct arguments and they sound like computer programming jargon. It can be intimidating.
It can be, yeah.
Let's break down exactly what the software is asking for using a real-world analogy. Let's imagine the spreadsheet is an old-school library card catalog.
I like that. So the first argument it asks for is the lookup value.
Wait, what does that mean in plain English?
What are you actively searching for? What is the patron asking the librarian for? You point this argument to an empty cell where you're going to physically type the customer's name later. So you just click that empty search cell.
Got it. And the second part, the table array.
The table array is the entire cabinet of drawers. Where am I looking? This is the total range of raw data you want the function to search within. You would highlight your entire master list of 500 cookie
Oh,
sales.
and here is where those named ranges we just talked about come in handy.
Exactly. Instead of highlighting A1 to D500 and dealing with absolute dollar signs, you can just highlight it once, name it paid orders, and just type paid orders into the formula. You are telling the librarian to look in the cabinet named paid orders.
Argument 3, the call index number or column index number. This is where people get confused. What does this number do?
This tells the program which specific piece of data, which specific drawer to bring back to you once it finds the right name. Let's say column 1 of your table has the customer names, column 2 has the specific cookie type they ordered, and column 3 has the total dollar amount they paid.
Okay.
If you want the search bar to tell you how much John Smith paid, you want the data specifically from the third column of that table, so you just type the number 3.
And the final argument, range lookup. It asks for true or false. Why would I type false?
You almost always type false in a business setting. False tells the spreadsheet engine, I want an exact perfect match only. If I accidentally misspell John Smith as John without an H, I want the spreadsheet to throw an error, not take a wild guess at the closest spelling, and accidentally give John someone else's cookie order.
So you hit enter. Now you have a fully functioning search bar. The customer says John Smith. You type John Smith into your target cell, hit enter. The VLOOKUP engine instantly scans vertically down the first column of your master list, perfectly finds John Smith, slides horizontally across a row to the third column, grabs the dollar amount he paid, and displays it right in front of you in a fraction of a second.
And an HLOOKUP is the exact same conceptual mechanism, just oriented horizontally instead of vertically. It searches across the top row of a table for an identifier and then slides vertically down a specific number of rows to retrieve the target data.
It is brilliant for pulling a needle out of a haystack. But if VLOOKUP is about retrieving a single needle, pivot tables are about entirely reorganizing the haystack so you can see its underlying structure.
Pivot tables are arguably the most powerful summarization and analytical tool built into any spreadsheet software. They allow you to organize, summarize, and view massive data sets from entirely different angles without ever altering or destroying the original raw data.
Let's stick with the cookie example because it perfectly illustrates the business problem. We have 500 rows of individual sales. The raw data lists the seller's name, the cookie type, the number of boxes sold, and the specific neighborhood they sold them in.
It's lots of data points.
That raw, chronologically entered list is great for keeping records, but it is terrible for making high-level strategic decisions. If I am the cookie manager and the regional director calls and asks, which neighborhood bought the most cookies overall? I can't answer that by staring at 500 random rows.
No, you definitely can't. If you tried to answer that manually, you would have to sort the entire list alphabetically by neighborhood, then use the AutoSum function on every little subgroup, writing a dozen different formulas. It would take an hour.
So how does the pivot table solve it?
With a pivot table, you just highlight the entire massive data set and click Insert Pivot Table. The software automatically creates a brand new, clean sheet.
It gives you a blank canvas, and it looks a little like a Rubik's Cube waiting to be solved.
Right. On the side of the screen, it gives you a simple list of your original column headers, seller, cookie type, boxes, neighborhood. And below that, it gives you empty boxes called fields. You just drag and drop those headers into the fields.
Just drag and drop.
Yeah. You take neighborhood and drop it into the rows field. Instantly, magically, the table scans all 500 rows, condenses all the duplicates, and lists every unique neighborhood just once down the left side.
But I still need the total boxes.
So, you take the box's sold header and drop it into the values field. The spreadsheet engine instantly calculates the total sum of all boxes sold for each specific neighborhood and cleanly displays it right next to the name. You can see in 2 seconds that the north side neighborhood bought a total of 500 boxes, while the south side only bought 50.
And the absolute beauty is, in the name itself, it pivots. You aren't changing the stickers on the Rubik's Cube. You are just twisting the layers to group the colors differently.
Exactly.
If the regional director suddenly changes their mind and wants to know which cookie type sold best to each neighborhood, you don't have to start over. You just drag cookie type into the columns field.
And the table instantly twists.
Now you have a beautiful cross-tabulated grid showing Thin Mints versus Samoas, perfectly broken down by neighborhood totals. It turns thousands of rows of incomprehensible raw data into a summarized, highly actionable executive dashboard in under 5 seconds. That is why pivot tables are legendary.
It really is.
Which brings us perfectly to our final core topic, Section 7, Visualization, Charts, and Color Theory. We've collected the data, we've cleaned the data, we've analyzed the data using advanced tools, but now we have to present the data. Because let's face the harsh reality of corporate life.
Yeah.
Your CEO or your board of directors absolutely does not want to look at a grid of 10,000 numbers, no matter how nicely you formatted them.
Exactly. They don't have the time. Data visualization is the graphical and structured representation of data. It takes the heavy cognitive load off the viewer's brain.
It just makes it easier.
It makes it instantly easier to see the results, spot the trends, and understand the conclusions ascertained from your hard analysis.
The textbook outlines how to convert data into visual charts. We won't sit here and describe the specific button clicks of inserting a chart, because that varies slightly whether you use Excel, Google, or Apple. But the core foundational elements of a well-built chart are universal.
Right.
If you skip these, your chart is useless. What makes a good chart?
A good chart must have clear, explicit elements that provide immediate context. First and foremost is the title. The title shouldn't just be a generic word like sales. That tells me nothing.
It needs to be specific.
It should give exact context, like Q4 cookie sales by neighborhood.
Then you have your axes, the vertical and horizontal lines.
Yes, the X and Y axes need to be clearly, explicitly labeled so the viewer knows exactly what the metrics are measuring. Are these numbers representing dollars, individual units sold, time in months, or distinct categories?
If you just have a bar going up to the number 50, I need to know if that's $50 or $50,000.
Exactly.
Data labels are another crucial element that amateurs often forget.
Data labels actually display the exact numerical entry for the specific data points directly on the chart itself. So instead of forcing the viewer to squint and guess if the top of that bar line reaches the 400 or 450 mark on the side axis, the exact number 423 is printed right on top of the bar. It removes all ambiguity.
And finally, the legend.
The legend identifies exactly what the different colors, lines, or pie segments represent. If you have a complex line chart comparing 2024 to 2025 sales trends, the legend is the little key that tells the viewer the blue line is 2024 and the red line is 2025.
Makes sense.
Without a legend, a multicolored chart is just modern art. It's completely unreadable as data.
Speaking of colors, the module ends with a really fascinating discussion on color theory in business spreadsheets. This is something I never thought about before reading the text. Color isn't just about making things look pretty for a presentation. It's a deeply psychological communication tool.
If we connect this to the bigger picture, spreadsheets use color to instantly convey feelings and messages without requiring the user to actually read a single number.
Wow, how does that work?
Color theory divides the visual spectrum. You have warm colors, your reds, yellows, oranges, and browns, which can be used to bring data visually forward to create urgency and aggressively draw the human eye's attention.
And the cool colors.
Then you have cool colors, your blues, greens, and purples, which naturally tend to recede into the background, making them great for structural elements, borders, or less critical contextual data.
But when we move specifically into the financial and business world, it's not just about what looks nice. There are very strict, universally accepted color conventions that you absolutely should not mess with, or you will cause chaos.
Absolutely. The financial convention is universally understood across the globe. Red explicitly indicates negative values, financial losses, or debits.
The phrase being in the red is universally a bad thing.
Right. Black, or sometimes green, depending on the software, represents positive values, healthy profits, or credits.
So don't mix those up.
If you present a massive financial dashboard to a board of directors and you decide to color your profit margins red simply because red happens to match your company logo, you are going to cause widespread, legitimate panic in that boardroom for about 10 seconds until you desperately explain your bizarre formatting choice. You do not mess with financial red.
And there is also the risk convention, which is basically the universally understood traffic signal model.
Right. When depicting safety items, project status updates, or corporate risk factors, business universally relies on traffic light colors because they require zero cognitive processing.
Green is good.
Green means safe, project is a go, or low risk. Yellow indicates caution, intermediate risk, or a project that is delayed but still salvageable. Red means extreme danger, high risk, or a critical project failure.
It's just instantly readable.
By strictly utilizing these established color conventions, you allow busy stakeholders, who often don't have the time or the desire to read every cell or analyze every underlying formula, to instantly gauge the financial health or risk level of an entire corporate project the literal second the spreadsheet opens on their screen.
So what does this all mean? We started today with the stress and chaos of a busy bookstore and a manager who needed instant, reliable answers to survive. We've seen how spreadsheets are the flexible workbench that makes those answers possible.
They really are.
They aren't just digital calculators. They are powerful logical engines. Through the precision of relative and absolute referencing, the logic of if functions, the retrieval power of VLOOKUPs, and the summarizing magic of pivot tables, they allow a single human user to tame millions of chaotic data points into clear, actionable insights.
Which is incredible.
And through charts and careful color theory, they allow you to communicate those insights instantly to the people who matter.
They're the vital bridge between raw data collection and actual data-driven decision-making. You simply cannot be a highly effective modern business professional without speaking the language of spreadsheets.
And that wraps up our deep dive into the source material for Module 4. I want to thank you so much for joining us in exploring the hidden mechanics of this truly indispensable business tool.
It's been a great analysis. Understanding the internal why and how behind the software clicks is what truly builds long-term data proficiency.
Before we go, a quick reminder. Please like, subscribe, follow, and share this feed to stay on top of your coursework and professional development. And we really want you to leave a comment because commenting is the perfect way to answer today's discussion question.
Here is the scenario we want you to think about and apply.
Think about a business you currently work for, or one you frequent regularly as a customer, like a restaurant, a retail clothing store, or a local gym. How could they specifically use a pivot table or a VLOOKUP to solve a tangible operational problem or track their inventory better?
That's a really good question.
Think about what their messy, raw data probably looks like on a daily basis, and how one of these advanced tools could quickly summarize it or retrieve it faster to help the manager. Drop your specific real-world scenario in the comments below. We read them all, and it's a fantastic way to apply these theoretical concepts to the real world.
I look forward to seeing what kind of daily data problems people solve.
Next time on the Deep Dive, we're stepping away from organizing and analyzing data and moving into the critical realm of protecting it. In Module 5, we'll explore the rapidly evolving, incredibly high-stakes world of cybersecurity.
That's going to be a good one.
And you might be surprised to learn just how vulnerable everyday business systems, even those simple CSV files we just talked about, really are to modern threats. Until then, keep analyzing, keep questioning, and we'll see you on the next Deep Dive.